Today, as a part of our video project in Engineering Material and Testing course, we have taken an experiment as a part of this project. The experiment is Izod impact toughness test on the metal samples. But before starting with the experiment, I would like to focus on a few lab regulations. Like every time we must wear safety glasses, closed shoes, and we must not bring any food or drink in the lab. And also we must not wear any loose clothes and jewelries for that. Now, talking about the experiment of Izod impact was conducted to know the deformation and toughness level of different materials or metals. For the purpose of this experiment, we have taken three metal samples, and they are steel, aluminum, and brass. This experiment was conducted on the Izod impact testing unit, and with a swinging pendulum which comprises in the testing unit, which measures the toughness of the material. Different material of metal possesses different toughness, which can be clearly identified with the force of swinging pendulum. Based on the toughness level of the metals, its usage and application is decided. Some applications require good toughness, like automobiles, so we need to have material of metal with a good toughness. Some of the applications such as like HVAC system, the heat ventilating air conditioning system, where we don't require that much toughness. So we will use a material which is having a less toughness property in that. So based on the test conducted on the Izod testing unit, we will figure out that which material will be good, tough, and which material will be less tougher, and based on that the applications are decided. Before starting the experiment, it is quite necessary to understand two terms, like what is Izod impact, what is the pendulum, and everything. So the energy needed to break the metal or plastic part or to produce fracture in the parts with the application of force is known as Izod impact. The load is applied until the metal part is broken. There was a great metallurgist Izod. Based on his name, this test came into existence in the 19th century. The testing unit consists of a swinging pendulum which plays an important role in the entire experiment. The test is based on the height of the pendulum and the amount it swings in the region. The sample metal is kept in a vertical position on the unit and the pendulum is released from certain height. The strength of the metal is identified based on the loss of the energy and loss of the height when the pendulum swings. This test is best useful for quality control department to check for the strength of the material instantly. The toughness of the material is higher when the deformation is.
My name is Arush Sharma. I am here to explain you about the calculations of as my part of working. So this is actually the figure which I will gonna discuss. Alpha is denoted by angle of fall is basically denoted by alpha, and angle of rise is basically denoted by beta. This is direct portion as you see is denoted as our specimen. We will stretch this part up to the angle of fall, that is alpha. As soon as it hits this that is specimen, it will deflect or move up to a certain point or an angle which is beta. So this is our weight mg, which is just as you can see is moving downwards, and this is the actual height which is denoted by a, and after the deflection the height of the hammer is denoted by b. As I explained earlier about the figure, m is denoted as the mass of the hammer which is raised to a specific height a, and this is the vertical height from the raised mass, whereas as the pendulum strikes after hitting the specimen, it is raised to a vertical height of b, as we can see from this figure. Now we have to calculate the potential energy, which is denoted by EP is equal to mga. A is the initial height of the hammer. After being released, the potential energy will decrease, as we all know, and kinetic energy will increase. Kinetic energy is denoted by Ek is equal to half mv square, where m is the mass of the hammer, v is the velocity. And we have to calculate both the potential as well as kinetic energy. Ek is equal to Ep. We have mga is equal to potential energy, and half mv square is equal to kinetic energy. Now we're gonna calculate the value of V from this relation. V square is equal to 2GA. V is equal to velocity, G is equal to gravitational pull, and A is equal to initial height, as we can see from our figure. V is equal to 2GA under the root. This will be the impact velocity. Now let us come to this portion. By using the trigonometric relations, we can calculate the value of A is equal to R1 minus of cos alpha, where alpha is the angle between the specimen and the initial height of hammer, as we can see from this portion. And B is equal to R1 minus of cos beta, where beta is the angle of deflection after it hits the specimen, as we can see from this part. Now the initial energy is equal to mGA, as we studied from this relation, mg into A. Now we will substitute the value of A is equal to R1 minus of cos alpha in this relation. So mg R1 minus of cos alpha. Mg, we can also write mg is equal to W, as we can see from this. W is equal to mg, which is going downwards. Energy after rupture, that is energy after hitting this specimen. We can write the energy after specimen is equal to mg into B, and we will substitute the value of B, R is equal to R1 minus of cos beta in this relation. So it becomes W R1 minus of cos beta. So now we have both the energies, initial energy as well as the final energy or energy after the rupture. Now we will subtract the energy absorbed by the specimen, which is also written as E is equal to ABS. Energy absorbed by specimen, that is this part, energy absorbed by this specimen. E is equal to EABS. We substituted the value of E from both these relations, WR cos beta minus of cos alpha. Or we can also write initial energy is equal to mGA, where mg is equal to W and A is equal to initial height as E1, and energy after rupture mgB. B is the height after the hitting the specimen, and mg as W. WB is equal to ER. So energy absorbed during the impact can also be written as mg is equal to A minus B. Now equating both the relations as WA minus B is equal to ABS. So we will now move to our concluding part, which includes the iso impact strength is also expressed in kilojoule per meter square or feet pound / feet square.
Hold the latch prevent bar up and insert the operating lever in the latch position. Insert the stop in the hole 1 to prevent the accidental release of the pendulum. Now we pull the pendulum to the right side and hold it against the metal safety brake. Now we clamp in the vise, but make sure the nose side is facing the pendulum and the short side is in the opposition. And with the help of the gauge, make sure the notch is aligned with the upside of the gauge. And we tighten up the specimen. Pull the pendulum to the right side and we'll hear a clicking sound, which means the pendulum has been latched, and we'll slowly release the pendulum against the latch. And now all set, our pendulum is ready to work, but make sure the pendulum is all clear. Now we remove the pin from the hole 1 and insert it in the hole 2, and we release the pendulum by pulling the operating lever. Here we go, and our pendulum has broken the specimen. We remove the stop pin and apply the brake and let the pendulum comes to rest. We repeat the same process. Hold the pendulum against the metal safety brake and remove the specimen. And after that we note the reading.